السلام عليكم ورحمة الله. Hello everybody. Welcome to our tutorial from zero to hero mastering Autodesk Inventor. We are in tutorial 2, swivel head bracket. In this video, we'll work with the assembly. We'll go to our Inventor, Home, Assembly. Place our fixed part will be the base, so I'll hit the base, click open. As I said before, the first part that we put it in our assembly have to be grounded, so I'll right click, don't click anywhere, just right click here and place grounded at origin. So the origin of my part will be, as we saw in our previous tutorial, hit escape. My origin will be the same as the origin of the assembly, the planes, etc., etc. Let me at the angle, sorry, the corner of my view cube. This is my home view will be. So I'll go here to my small arrow, go down, set it as home, put the view. And this is my front view. It's not top. I'll click here, go here at current view, and this is front view. Go back to my home. This is my home view. Hit save. And this is the assembly. We call it the same as the project swivel head bracket. Okay. Save. It's okay. So in the base, we said that we'll put my bushing with press fit. Where's my bushing? Here's my bushing. Hit open. Click it anywhere. Escape. We need only one. We go to our constraints. We have cylinder inside the cylinder. So you'll go to insert in this hole. Okay. And we'll shift with our middle wheel the neck of my bush. It have to be fixed inside. Okay, now it's rotating 1 degree of freedom. If you go to view degrees of freedom, is our degrees of freedom, we can see that we have still a rotating. I don't want this part to be rotated, so I have to give it another constraint in order not to rotate. I'll hit the constraint. Okay, and go to bushing, origin of the bushing. Let us take the XZ plane. This is the XZ plane of the bushing. Okay, and we'll go to my base, origin, XZ plane. They have to be made or flush. This doesn't matter, but at 0 distances. Hit OK. Now, view degrees of freedom is still, and my rotating degree of freedom is gone. So my bush is press fit. Mustn't rotate inside my head, inside my base, sorry. Then, here I'll put a shaft, but we didn't model a shaft. In this tutorial, those collapse all, we'll create a shaft inside the assembly by going to design tab, design, and we have shaft tool here. We'll click the shaft tool, and as we can see here, give me a preview of a shaft. It's the previous shaft that I did here. We can see that shaft is consist of sections here, 1, 2, 3 sections. They are cylindrical sections. Okay, you can create a cone section, you can create a polygon section. etc., etc. Okay, so I'll delete my sections. I don't need them. Okay, again, sorry, shaft, click here and delete, and keep only one. The polygon, I don't need it as a polygon. We'll create it as cylinder. What is it? No, we'll change the shape. Shape will change it from here to cylinder. Okay, then we change the shape to a cylinder or cone, or you can take a polygon, etc., etc. Let's go back to our shaft. Where is my shaft? Here's my shaft. And this is my shaft. We have section 1, 2, 3, 4, 5 sections, or 5 cylinders. The first cylinder is 520 by 22. I'll go here to my inventor, click these 3 dots, and the diameter of my cylinder is 20, and the height is 22. The diameter is 20, the height is 22. Okay, this is my first section. Okay, I hit OK. Okay, create me the first section. How to continue? Click the shaft, right click, edit using design accelerator, and we'll continue. We'll add another cylinder. Add, click the cylinder and use another cylinder. We give it dimension, diameter, and height of the cylinder. The diameter of this cylinder is 50. What is it here? Not 50. This diameter is 36, and the height is 80. Go back there, give it 36 by 80, and 36 diameter, 80. Okay. Next, we'll add another section, and this section will be, the height is 10 and the diameter is 60. We'll give it, click here at the dots, 60 and 10. And okay. We'll add another cylinder, and this cylinder have 550 and the height is 30. And this shape we'll create it after. We'll create a cylinder here, and then we'll cut in order to have it to have this shape. Okay, so 30 the height and 50 diameter, 50 diameter of 50, and the height is 30. Okay. Next, the last cylinder is, have here M18, which means my cylinder is 18 diameter, and the height is 34. I go back here, give it another cylinder in this section, hit the 3 dots, 18, and the height is how much? 34. 34. Hit OK. Hit OK. Save. Click OK. And my shaft is, I click the shaft, give it a steel alloy, and hit save. I create the base cylinders, what we call them, section of my shaft. Now I'll work with the shaft in order to have it the same shape as we see in our drawings. First of all, we'll add a thread here, 24 thread, 18 by 2.5. Okay, let's have a chamfer. put a thread بعدين chamfer. Okay, so the chamfer will be with the thread 24 and M18 here. Go back to our shaft. Here's my shaft. Click the shaft, right click and edit using design accelerator, and select the section that you will edit. I'll edit this section. I see it's blue. This section, the active section, is change the color. And in this section, we'll add a thread. We'll add a thread. Here's the parameters of my thread. Then the whole section is L34. The chamfer of my thread will be how much here? 2. Okay, Z, it's this chamfer, Z2. And LT, length of thread, is 24. As we can see here, this is the length of my thread. And type of thread is M18, isometric trapezoidal, no isometric profile. Okay, 18 by 2.5. And my all parameters is set. My thread, I'll choose the thread type from here. We have ANSI, ISO, etc., etc. First time we're working with threads. So isometric profile thread M. That's why the letter M for isometric profile. Okay, M18 by 2.5, the pitch of my thread. And here we have the chamfer and we have the length of my thread. Hit OK. Okay. My thread is ready. Next, we'll cut this shape here. The shape will be this, as we can see it here. We call it a wrench in the shop. We call it a wrench. Okay, let's go back here. What section we'll work with? First of all, we'll edit using design accelerator. Okay, we'll go to this section, and here we'll add the wrench. Here we don't have wrenches. No, then we go to other. Okay. Chamfer fillet here. Add a wrench. And we open me. As we can see, here's a dialog for a wrench. You can, as usual, click these 3 dots in order to add parameters of my wrench. Then D is 50, we understand. L is the L of the wrench. This is the X of my wrench inside. Okay. The W, can you see? The W, oh, where is it? The W of my wrench, this is my W of my wrench. Okay, alpha, if my wrench is with an angle, so alpha is 0. Okay, L is the length of my wrench. Let us see. Go back here and see. So my W is 36. My wrench is the same height of my start at 0 and ends at 30. Okay, let's go back here and give it W is 36. L is 30. X is 0. Start from 0. Yep. So we don't have X. It starts from the beginning till the end of my section. It's the same height as, or the same length as the section. Okay, W is 36 and hit OK. Hit OK. And my cut is ready. My cut is ready. Next. Save. Okay. What else we can do with our shaft? Then we have something here. We'll add a chamfer of 2. because it's in both sides, and we have a hole by 6 here in order to put my pen. Then the center of the hole is 12 down, okay, and 5 6, but we have to put a chamfer. Let's go and work with this section. Let's go here, right click again, edit using design accelerator, select the section. This section we'll work with. Okay, first of all, we'll add the chamfer. My chamfer is 2. Okay, then here's the end of, you can add chamfer from this end or from the other end. You can add a fillet, add anything. Okay, Owen. Okay, you can add fillet from the other if you wish, etc., etc. This is the chamfer that how we put it. Next, what we'll do, we'll have a add through hole. Add through hole. Can you see he put a through hole here? Okay. Where is it? Here. Again, we hit the 3 dots in order to have its parameters. Okay, then my section is 20. All of it is 22. The hole is 6. And my hole is 6. Okay, chamfering, we don't need any chamfer in the hole, 0. We don't need any angle. The distance is 12. And be sure when you click on any other adjustment that my distance is from here. 12. Can you see? My hole is moved 14. Click on any other parameter, it moves from here there. And I need 12 from here. Okay. Otherwise, you take measure from the other edge. You are measuring from this edge. It goes in the contrary to the other side. You take the other edge to put the distance. Okay. Okay. Save. Okay. My shaft is ready. Shift with your center mid. This is my 6 hole. Okay, this is my wrench. And this is my thread. Save. Hole. My hole will rotate inside the bushing, so I'll assemble my cylinder inside the cylinder. It will be from here to here. Okay, okay. And my shaft is rotating inside the bushing. Rotating inside the bushing. Home. Save. Let us bring our swivel head base. Swivel head. Open. This is my swivel head. Escape. As we can see, it's the same shape. We cut it inside the swivel head in order to put it as press fit. Sorry, clearance, little bit clearance. Here sliding fit we have a little bit clearance, we'll have it. So I'll constrain first. I'll constrain the center with the center. Can you see? You click the cylinder, I'll click the cylinder with the center with the center at 0 distance. Put 0 little okay. And now my center is constrained with this. And see it's in the center. This is in the center. But I have to constrain my faces. So I'll hit constrain. Okay, made this face with this face. At 0 distance, hit okay. Now when I rotate, will be rotated together because I constrain face with face. The last thing that will be constrained is this face with the base of my head at 0 distance, and it's fully assembled. Hit OK. Now when I move, we'll move together. Can you see the hole down? When my head moves, the shaft will be moved. I'll fix my shaft from down with the collar and from up with two with washer and two nuts. Let's bring our collar place. Collar, this is my collar. Open. Okay. How to constrain this collar? Then this hole of the collar must meet this hole of the shaft, and the center hole will be the same center as the shaft. We'll create two mate constraints with center line. I'll click the inside circle. I click the inside circle, and they are now mated with at 0 distance. It's OK. Okay, and next I'll hit the cylinder and hit the inside, the center circle of my collar. Hit OK. Now they are rotating together. Now they are rotating together. And if we look here inside, we can see it's open in order to put my pen. My two holes, 6 mm holes, are mated together. Okay. And in our design, we create that this color will be mated with the face. Okay. Save. Okay. Now we'll work with our standard parts and go to place from content center. Go to our exploded assembly, or we can see them here. We have ISO, we have ISO, we have ISO. Then all my standard is ISO. We need a pen, we need a washer, and we need two nuts. So I'll filter to ISO standard. Is it filtered? Yes. When it's checked, it's filtered to ISO standard. Okay. Here we'll go to shaft part. We have pens here. We don't have pens here. Then we have pens here. We need a cylindrical pen. Okay, number 23386M6. 23386 M6. Oh, sorry. The height of my pen is, let's see, 60. M6 by 60. 6. M6 is this is the tolerance of the pen, and 60 is the height or the length. 60. Where is my 60? Go down and select 60. Hit OK. So this is my pen. How to constrain the pen? In order to constrain the pen, again, we have cylinder, center of this one with the center of this one at 0. Hit OK. Now my pen is inside, but it's going there. How to constrain it? And I'll hit constrain. My color, let's go back to my color. This is my color. And the diameter of my color is 60. Okay. So I'll go back here. I'll constrain this face. Okay. With my colors plane, with the color open the origin. Let us extrude with the XZ. This is my XZ plane. And the distance is 99. I need it minus 60 by 2. And as we can see, comes at the end. We give it from this face to the plane, and we take it out by 30. But okay. Now my pen is fixing in real life the color with the shaft, and they are rotating together. They are rotating together. Next, put it there. Okay. Now we have to add washer and two nuts. Go to fasteners, washers, plain washer. What's the number of this washer? 7090 18. 7090 18. So go back here. 7090. Okay. If you wish, you can use auto drop, as I said before. We take this cylindrical face, okay, and we'll put it here at this face. Hit okay, and automatically Inventor calculates the diameter of my washer is 18, and he put it here and constrain it. The same way I'll do with the nuts. Go to the nuts, fasteners, nuts, hexagonal nut. My number is 3035 M18 3035. I'll go back here to find 3035. Double click. Again, he's asking for a thread. This is my thread. He didn't take it. Click the thread. Now he took it. Click the face that you want to fix your nut. I'll fix it here. Okay, I need another one. We'll click the face. So that's the thread. Click the face of the nut. Hit okay. Escape. Now my assembly is ready, but my nut and washer, they have to go with the shaft. Otherwise, they will be untied. Okay. So what we'll do, we'll constrain again. Let us constrain this face. Okay. Flush with this face. Hit apply. Now I'll constrain angle constraint, angle, direct angle constraint, this face with this face at 0 angle. Hit OK. When I'm rotating, they are rotating together. But still, I have the washer. I have the washer. If I go to degrees of freedom, here's my degrees of freedom, still the washer are rotating. So I have to fix my washer. Go to the washer, open this one, open the origin of my washer. We have a work plane. We have a work plane for the washer. It's outside, doesn't matter. You can use the origin or you can use this one. Okay, and I'll go back to assembly, a constraint, angle, direct angle to this one, 0. Okay, now the rotating is gone. The rotating is okay. That's it. Do we have anything? No. So this one is fixed. Okay, this one is fixed. We are rotating all these. Of course, these rotations for my pen down. You take out degrees of freedom. How to drive this assembly? Then my swivel head, I think it will rotate like this at an angle. It will rotate at an angle. So we can now go to our assembly, constraint, head this face, not the incline, the straight face of my head. Okay, angle, direct angle, the angle will have to be 0. Okay, and he'll we'll name it as drive. Name it as drive. Okay. Let us say you degrees of freedom. Only 1 degree of freedom till it's rotating inside. My pen is rotating inside this one. We don't care. Keep it rotating. Same, it's fixed. Okay. Just drive my assembly. How to drive my assembly and collapse all. In order to see all the constraints that you have them, you have to go here. And this is all the constraints that we add to my assembly. Go to drive constraint, right click drive. Okay. Give it 90 degrees. Okay. Go back. 0. Give it minus 90. Go. And this is the way that it will work. The way that it will work. Okay. Hit these. Click here for repetition. Let us give it 5 degrees. And let's see, start and start. And let's see what's going on. It will be working this way. You can give it here 8. It will be, sorry, 8. Okay. Now we have 1, 3, 4, 5, 7, 8. Then this way, this is the motion of my, okay, here, it's saved. But in assembly, I need it to be straight. In assembly, I need it to be straight. So I'll go back to my, here, and change it here to 0. Because I need in my assembly, in my section to be at 0. You can, of course, record, as I told you. We can record our video. We can record our video and then put it back to 0. There. This way we finish our assembly. I hope you enjoy it. You gain new skills here in creating shafts, editing the shaft, working with pen and how to constrain the pen. Thank you very much for joining and watching. If you have any questions, you just drop them down. Keep tuned and see you next video.